In this video, we are going to talk about how to create a confusion matrix for a multi-class classification problem. And then we are going to talk about how to calculate the specificity, recall, precision, and F-score for each class. And also, at the end of the video, we are going to talk about how to calculate the weighted specificity, weighted recall, weighted precision, and weighted F-score for this problem. So please stay tuned. So now let's talk about multi-class classification confusion matrix in Python programming language using the Sklearn package. So first of all, we define a variable, let's say called yTrue, which is the actual labels. For example, this means the actual label for the first sample is 0, and the actual label for the second sample is 0, and etc. And also we define another variable which is called y_pred, which is the predicted labels. So for example, as you can see, for the first sample we have predicted 0, for the second sample we have predicted 0, and for the third sample we have also predicted 2. So as you can see, the actual label is 0, but we have predicted 2. So that's it. And here we have defined another variable which is called labels, which you can see is the labels name, so they are 0, 1, and 2. So here we have defined 3 variables. Now in order to calculate the multi-class classification confusion matrix in Sklearn, so we can simply type from sklearn.metrics, we want to import the confusion matrix, and then we use that confusion matrix which we have imported, and you can see that the first argument that we should pass is yTrue, I mean the actual labels. So I simply pass that, which is the yTrue variable which we have defined here, and the second argument is the predicted labels. So we have defined a variable, let's say called yPred, so I pass that because you can see that we have called the predicted labels y_pred, so I pass that variable, and the labels which we are going to use is the labels variable, which is 0, 1, 2. So it means that we have a multi-class classification problem. That's it, and I store the results in a variable, let's say called CM. CM in my mind stands for confusion matrix, but you can choose whatever name you want because this is totally arbitrary. Then I simply print the CM variable, and if I run the code, you can see here is the result, which is the confusion matrix. But now let's make it more beautiful by converting it to a pandas data frame, and because you want to see the labels, I mean 0, 1, 2, so we want to add 0, 1, 2 here, and also 0, 1, 2 for the columns. So let's do that. But now let's convert the confusion matrix to a pandas data frame. So in order to do so, first of all, we should import the pandas package. We should import pandas as a PD, that's it. And here I want to convert the confusion matrix to a pandas data frame. So I simply type pd.dataframe, and I pass the CM variable to this function in order to convert the confusion matrix to a pandas data frame. And then I store that in a variable, let's say called cm_df, which in my mind stands for confusion matrix, which is a data frame. But remember, we want to put labels in the rows. I mean, you want to assign the labels for the row names. So I do that by simply pass index equals to labels. And also, I want to have labels for the column names as well. So I simply type columns is equal to labels. So now if I print the cm_df, and if I run a code, you can see here's the confusion matrix which has been converted to a data frame, and you can see now it looks better. But now let's talk about the interpretation of these values in this confusion matrix. So remember that the rows are the actual labels and the columns are the predicted labels. So for example, this 2 means there are 2 cases which the actual label is 0 and also the predicted label is 0. And for example, this 1 means there were 1 cases which the actual label is 1 and also the predicted label is 0. And for example, this 3 means there are 3 cases which the actual label is 2 and the predicted label is 2. And for example, this 1 means there are 1 cases or as a matter of fact, there is one case. It is not plural, it is singular. So there is one case which the actual label is 0 and the predicted label is 2. So the rows are actual labels and the columns are predicted labels. And here's how to interpret the multi-class confusion matrix in Python programming language in Sklearn. So now here's the confusion matrix, and we are going to create something like this. So we can see, for example, for recall, we have a recall for class 0, and also we have another recall for class 1, and also we have another recall for class 2. So as you can see, for every class, we have the corresponding evaluation metric. So we are going to calculate that evaluation metric for each class. So we are not going to have one recall, we are going to have multiple recalls because now we are encountering with a multi-class classification problem. So here we have 3 classes. So as a matter of fact, we have 3 recalls, and we have 3 specificities, and we have 3 precisions, and etc. So in order to explain this table, let's talk about, for example, the class 0, and let's calculate a specificity, recall, and precision for class 0. So for calculating all this stuff for class 0, we should build a confusion matrix like this. So we build a confusion matrix, a 2-class confusion matrix. So we say 0 and not 0, 0 and not 0. So these are the actual labels and these are the predicted labels. And for example, we consider 0 as the positive label and not 0 as negative label. And we do the same thing for the predicted labels. So let's fill in this confusion matrix, and let's talk about this cell. This cell means how many cases the actual label is 0, and also we have predicted 0. So as you can see, there are 2 cases which the actual label is 0, and also we have predicted 0. So here we should put 2, so that's it. We write 2 here in this cell. And now let's talk about this cell. This cell means how many cases the actual label is 0, but we have predicted not 0. So there were 1 cases which the actual label is 0, but we have predicted not 0. So we have predicted not 0. So there were 1 cases which the actual label is 0, and we have not predicted 0. So let's fill in this cell as well. And now let's continue and talk about this cell. So this cell means how many cases do we have which the actual label is not 0, but we have predicted as 0. So we can see that there were 1 cases, or as a matter of fact, there is 1 case because it is singular, not plural. So you can see that there is 1 case which the actual label is not 0, and we have predicted as 0. So let's fill in this cell as well. And now let's talk about this cell. And this cell means how many cases do we have which the actual label is not 0, and also we have not predicted as 0. So how many cases do we have which the actual label is not 0, and we have predicted as not 0. So we can see that there are 5 cases, which the actual label is not 0, and also we have predicted as not 0. So that's it. And now let's assign the corresponding labels because we need them for calculating all these stuff. So as you know, this is the true negative. What do I mean by true negative? I mean it was actually negative, and we have truly predicted as negative. So it is true negative. So the label of this cell is true negative, and the label of this cell is true positive. It means that the actual label was positive, and also we have truly predicted as positive, so it is true positive. And the label for this cell is false positive. It means that the actual label was negative, but we have falsely predicted as positive. And the label for this cell is false negative because the actual label was positive, but we have falsely predicted as negative. So now let's talk about how we can calculate the specificity, recall, and precision for this confusion matrix. So as you know, the formula for calculating the specificity is true negative divided by true negative plus false positive. And if we plug in these values, so as you can see, the true negative is 5, and false positive is 1. So if you plug in these values, you can see that the specificity would be 0.83, which is true. And let's calculate recall, which is true positive, divided by true positive plus false negative. And if you plug in the values, you will get this, which is correct. And also let's calculate the precision, which is true positive, divided by true positive plus false positive, which if we plug in the values, you will get this. But now let's talk about how we can calculate F-score, or sometimes called F1 score. So in order to calculate the F1 score, here is the formula: 2 times precision times recall divided by precision plus recall. And if we plug in precision and recall, we will get 2 divided by 3, which you can see it is correct. So this is the F1 score of this confusion matrix. So after calculating the recall and precision, it's easy to calculate F1 score as well. But before going to Python, let's talk about one thing which we really need in Python. So here's the confusion matrix. And let's denote the recall for this confusion matrix as recall 0 positive. It means the recall when the 0 is considered as the positive label. So recall when 0 is positive label is true positive divided by this, which we have talked about, and here's the value. And also we have talked about the specificity formula and the calculations. So the specificity when the 0 is considered as the positive label is this, which you can see here's the result. But now let's change the positive label. So let's copy this. And now let's change the positive labels. So by changing the positive label, I mean, for example, let's change not 0 as positive label and 0 as negative label. So let's change that. And as you know, when we change these labels, so the true positive and true negative and these labels would change as well. So this would be true positive, this would be true negative, and this would be false negative, and this would be false positive. And now let's calculate the recall when the 0 is considered as negative label. So recall when 0 is considered as negative label, again, the formula of recall is true positive divided by true positive plus false negative. But as you can see, the true positive location has changed. In the previous confusion matrix, true positive was this, but now it is this value. So true positive, which is 5, divided by true positive, which is again 5 plus false negative, which is 1, is 5 divided by this. And if you look at this slide, you can see that the recall of 0 when it is considered as negative is exactly the same as a specificity when the 0 is considered as positive label. So this is the thing that we need in Python. So if you want to calculate the specificity for the positive label, for 0 as being positive label, you can calculate the recall when 0 is considered as negative label. So now, as you can see, we have imported NumPy as NP, and also we have imported pandas as PD, and here are the actual labels, and this is the prediction labels, and this is the label names which we have defined as labels. So for every label, we want to calculate precision, F1, recall, specificity, and etc. So let's do that. So we simply type for every label in the labels variable. So for every label, we want to calculate all those stuff. So now here we want to use a function which we need to import that. So I simply type from sklearn.metrics. You want to import a function which is called precision, recall, F-score, and support. And you can see that the name of the function is very long, and I will explain that. So let's use this function. And remember that the name of this function is precision, recall, F-score, and support because it returns 4 values. The first one is the precision, the second one is recall, and the third one is fscore, and the fourth one is the support. And now I pass something like this, which I will talk about this by the end of the video, but not now. Please wait a minute. But remember that I will explain this by the end of the video. So as I've said, this function returns 4 values. First of all, precision, then recall, and fscore, and support. So let's store all the results in 4 variables. So this is the first variable, which is precision. The second one is recall. The third one is fscore. And the fourth one is support. But now, for example, if I print the recall, for example, if I print this recall variable, and if I run it, and before that, let's print the labels as well. So let's print the labels. So I want to print label, and I want to use this in order to make it more beautiful. So this is the label variable, and if I run the code, you can see for every label, label 0, label 1, and label 2, this recall returns 2 values. The first one is when this label is considered as the negative class, and this second value is when this label is considered as positive label. So for every label, each of these metrics contains 2 values. The first value is when the label is considered as the negative label, and the second value is when this label is considered as positive label. So that's it. So because you want to make a data frame at the end of this code, so let's define a list which is called result, for example, and inside this list we are going to store the results for each label. What do I mean by that? I will explain it. So for example, for the first label, we are going to append to that result list. What we are going to append? We are going to append a couple of values. The first value which we are going to append is the label itself. The second value which you want to put in this list is specificity. And remember that a specificity is the recall of the negative class, is the recall when this label is considered as negative label. So if you remember, I've told you that each of these metrics consists of 2 values. The first value, the value at index 0, is when it is considered as negative label. So if you want to calculate recall for the negative label, we can simply type recall sub 0. It means recall for the negative label. It means recall when this label is considered as negative label. So this means this is equivalent to specificity. So this is specificity. And then we want to add the recall itself. Recall for the positive class. So I can use the recall variable, and I pass 1 because the value at index 1 is when the label is considered as positive. So recall 1 is the recall itself. And then we need the precision for the positive class, and also the fscore variable, also for the positive label. So we are appending these values. So we are appending this list which contains these values to the result variable. And now we want to convert the result variable into a pandas data frame. So that's very easy. We can simply type pd.dataframe, and we want to convert the result variable into a data frame. And the columns are, the first column, as you can see, is of the label. So the name of the first column is label. The name of the second column is specificity. So I simply type specificity. And the name of the third column is recall. So that's it. And the name of the fourth column is precision. And next one is fscore. So that's it. And for example, I want to store the result in a variable, let's say called df. And now if I print the df variable, and if I run the code, you can see here is the result, and these are for this line, which let's delete this line. And if I run the code again, you can see here is the result, which you can see for every label, we have a specificity, recall, precision, and fscore. But now let's talk about this, which we have talked about, and we have said that we are going to talk about this by the end of the video. And now it's time to talk about this. So first of all, let's print these. So I want to print these two lines. And also let's print something in order to make it clear that we are printing these for each label. So now if I run the code, you can see, for example, for label 0, as you can see, the y true, is 0, 0, 0, so it is true, true, true. So this is an indicator which indicates that these three values are this label, 0. And the other one are not this label, they're not 0. And for example, for vypred, you can see that this is an indicator. So as a matter of fact, this is an indicator, which you can see that it says the first value is 0. This value. This is this label. This is not, but this is 0, which is this label. And the rest are not this label. So as a matter of fact, you can see that these are indicators. So for every label, we have specify an indicator, a label indicator. So here we have to find a label indicator. And if you check out the documentation of Sklearn for this function, you can see one of the things that you can pass for ytrue and ypred is label indicator. So this is exactly the label indicator. So for example, for label 1, it means which of these values are label 1. So you can see these are not label 1, so they are false. But these three are label 1, so they are true, the rest is false. And also in this ypred variable, you can see these are not 1, so they are false, but this one is 1, so it is true. This one is 1, so it is true, and all the rest are false. So as a matter of fact, this is a label indicator, and this is one way to pass ytrue and ypred to this function which we have used in this tutorial. So that's it. But here is another question. How can we get something like this, which you can see this is the average specificity, average recall, and average precision, also average f-score of this problem? And now in order to do so, we should use this support variable, and I will explain what do I mean by support. You should wait a minute. So here we add the support value and support for the positive class. And again, you should wait a minute. I'm going to explain what do I mean by support, and also I should add this as well in the names of the columns. And if I run the code again, you can see here is the results. And this support means there are 3 cases which the actual label is 0, and also there are 3 cases which the actual label is 1, and also there are 3 cases which the actual label is 2. So now let's talk about how we can calculate the weighted average of f-score, precision, recall, specificity. In order to do so, first of all, we should define the weights, and you will see what do I mean by weights. So we should divide the support column, the values in the support column, by the summation of the values in this column, the support column. So for example, here, if I print the W and if I run a code, you can see here are our weights, which you can see it is 1 divided by 3. So why it is 1 divided by 3? Because this 3, every value in the support column has been divided to the summation of the support column. The summation of the support column is 9. So 3 divided by 9, which is equal to 1 divided by 3, is this value. And that's it. So here are the weights which you should multiply to each value in these columns. By saying these columns, I mean the specificity column, recall column, precision column, and f-score column. And now in order to multiply these weights, we can do this. We can simply use these columns, specificity, recall, precision, and f-score. So I should pass the name of these columns in a list. Remember, you should pass all the names in a list. So this is the list of columns which you want to use. And then we want to apply a function, and that function is going to be a function which is going to multiply the values to this weight. So that's it. So we are going to use a function. We want to define a function which takes each column, and it is going to multiply each column by the weight. And after multiplying that, it is going to calculate the summation of that. And you will find out what do I mean after running this code. So, and also let's pass axis equals to 0 because you want to multiply this weight to each column. That's it. And I store, for example, the result in a variable, let's say called df underscore summary. And now if I print the df underscore summary, if I run the code, you can see here is the result, which you can see the weighted average for specificity is this, the weighted average for recall is this. So you can see this is the weighted recall, this is the weighted specificity, this is the weighted precision, this is the weighted f-score. But remember that except the specificity, so except the specificity for other metrics, we have simpler way of calculating the weighted average for recall, precision, and f-score. For doing so, we can simply type from Sklearn metrics. You want to import the recall score, the precision score, and the F1 score. And then we, for example, we use the recall score in order to calculate the recall, and we passed the true labels, the prediction labels, and also the labels, and also the average, which we are going to use is the weighted average. So that's it. And let's store the results in a variable, let's say called output. And if I print the output variable, and if I run the code, you can see here is the recall, which is exactly the same as this. And now let's calculate the precision. So if I run the code again, you can see here is the result, which is exactly the same. And also let's calculate F1 score. So if I run the code again, you can see it is exactly the same as this value. And I don't know whether you know about F beta score or not, but as a matter of fact, F1 score is a special case of F beta score. So now I really suggest you to watch this video, which is on the screen now, which is about F beta score.